Hello there, and welcome to this OCR J276 GCSE computer science video concerning threats to computer networks. In this video, we're going to be looking at different threats to networks, as you can probably tell. So, let's get cracking. So, today we are looking at those different threats that you can see. So, let's get cracking away. We can see the learning outcomes for today's lesson. Sorry, hiccuped. And you can see what we're going to be looking at today. So, network threats occur for a variety of reasons. It could be someone wanting to steal information. It could be someone wanting to damage or disrupt a service. It could be someone who is accidentally configuring something. So network threats occur, network threats happen, and unfortunately most of the time it is for some form of malicious intent. So the first type of threat we're going to be looking at is malware, which could be any form of virus, Trojan, rootkit, worm, spyware, crimeware, or adware, as you can see there. So a virus is just like you get in the human body, something that causes damage or disruption inside a computer system. A Trojan is a form of virus, a form of malware, which appears to be something else, and it's named after the horse of Troy. Do some Googling for that one to work out why it's called that. But it appears to be something it's not. So it might be an image, which they might say, download me. And when you download it and you open it up, you'll then run the virus. Rootkits are used to access the root interface of servers and networks. Worms spread themselves out across a network or via email servers. Spyware is used, strangely enough, to spy. Crimeware for illegal things. So, for example, ransomware is a form of crimeware. And then adware is used to install advertising and general pop-up nuisances on your computers. We've got phishing as well, and this is an image which I've just stolen off the internet, I'm not going to lie. And it's an example of a phishing email. So you might see this email and first of all think, oh, it's got the Amazon logo at the top, it's got the proper stuff at the bottom, this looks legitimate. However, it's not. If we're having a look at the from section, management at amazoncanada.ca, we can see they've not got the correct domain name. It all looks very generic. Normally there's some sort of warning associated with it or some sort of link to click onto. And yes, it does look legitimate from the first glance, but then the more you look into it, the more you're thinking, actually, you know what, this is a bit of a scam. And that's what phishing is. It's a way to try and get information from a legitimate source. So, for example, in this case, an Amazon customer, and then use it for naughty things. So in this case, we've got someone trying to get someone's Amazon login information. So what I want you to do, first of all, what are the different types of malware? What do they do? What is phishing? How can phishing take place? So give the video a quick pause and we'll move on. So up next, we are going to think about social engineering, and this is a way of getting information, getting confidential information that's not readily available in the public domain, and it takes a bit of a while to do it. Social engineering is the confidence tricking of the internet. So getting access to someone, building up a rapport to someone, being able to find out information about someone, and then taking their information is social engineering. So it's all about building up a relationship with someone to find information or to take information or to get something and then terminate the relationship. So social engineering uses social networking, for example, to be able to build up a communication, build up a relationship, a rapport with someone, which can then be exposed in the future. Brute force attacks, I couldn't help myself putting in the picture of the Incredible Hulk there. Brute force attacks is a systematic way of trying to, for example, break into a login system. So if you've got a mobile phone and you try the password 1234, it doesn't work. Let's try 5678, doesn't work. Let's try 246, doesn't work. Let's try 1024, doesn't work. Let's try 6922, doesn't work. A brute force attacks is just about chipping away until you get the correct information, so then you can log in. Mobile phones come with a guard against this. So for example, if you try to log in, if your phone gets stolen and someone keeps trying to log into your phone, it just won't let them in. So brute force attacks, trying to chip away consistently. We've got denial of service attacks, and this is where you've got a server targeted and basically it gets flooded with information so it doesn't know what to do with it. So we've got a target server here, and what the attacker is doing is using multiple devices to then be able to attack and take down a server because it's being flooded with traffic. It doesn't know what to do. There's also a distributed denial of service attack, which then uses many zombie accounts, more than one attacker launching the attack to try and take it off. And again, if you've got a distributed denial of service attack, it's harder to trace, and because there's more of them, they can do more damage. So what I want you to do now, show your threats of network, social engineering, brute force attacks, denial of service attacks. Give the video a pause and we'll move on. So what we're going to look at now is data interception and theft, and what this is all about is if we've got a wireless network, essentially being able to snoop in and find out what's going on and intercept the data which is being sent across the network. So when we're thinking about data interception and theft, it is about data which is being sent or received wirelessly, being able to find out what that information is, and then using it for your own means. So if you're in a public unsecured network and you're logging onto your online banking, someone could be there quite happily with a packet sniffer and then seeing what information is coming out and getting your information. So data interception and theft, if you secure against it, you'll be fine. SQL injection attacks, I recommend you pause here and have a quick look at the SQL functions procedures video, because then you can get an understanding of what SQL is and then carry on looking at this, but then we're going to talk about this through now anyway. So we can see here on the right hand side we've got someone trying to attack an SQL server database, and we can see that the link going in, students.com student ID equals 117 or 1 equals 1, because 1 is always going to be equal to 1, it's always going to evaluate to true. So at which point then, because it's true, you've got the access, you can then say select everything from students, where student ID equals 117 or 1 equals 1, which is then going to return all the information for the students. So if the students table is holding student loan information and credit card information for student loans, don't know why they would do it, but there you go. But then all that information will be returned. If you're thinking and you're a company such as Sony and you're holding multiple pieces of information on people inside a database, SQL injection attacks are bad. You can see from the image on the left hand side, we've got a username and password, and then that is going to select star from users where username is universe and the password is password. What this is going to do, the link below it, is it's breaking the SQL code and then it's putting in that all equals 1 equals 1. And then the password is just whatever you want it to be. So then it's tricking it into thinking that it's got valid information, because the SQL injection attacks something and it only can be protected by the code it's written. The code is only as intelligent as the person who's written it, so you need to make sure you're developing against that. We'll look at that in another video. And again, poor network policies. Apologies for the spelling mistake on here. I've not been able to find a better image, but network policies govern particular areas. So for example, if we look at backup, if you work for a company and they only take a backup every year, that's a poor network policy. If we have a company and according to their acceptable usage agreement, it's fine for people to download and install their own software, it's a poor network policy. So good network policies mean that there can be rules, there can be structures, there can be things put in place to protect a computer network. So there we go. That's what I want you to do now. Give the video a quick pause and get those tasks done. So that's it for threats to networks. There is a follow-up video which is called Prevention to Networks, Threats to Networks. I highly suggest you watch that, because then you get the flip side. How can we guard against some of these things that have happened here? Hope you enjoyed the video, and I shall see you later. Bye bye.